Good morning. I am Professor Adimurthy, Faculty, Department of Automobile Engineering, BNDES Vachinamita Mahada, PG Electrical College of Engineering and Technology. Now I am going to demonstrate the setup that is used for the performance test on a single cylinder 4-stroke petrol engine. So the details of calculations and the procedure already we have discussed in the earlier video, and now in this video I am going to explain you the various components of the setup and how the experiment will be conducted. Now this is the total setup for single cylinder 4-stroke petrol engine. This is the test rig, and here we have the engine, and this is the motorbike engine. It is of basically Bajaj caliber 4-stroke petrol engine of 110 cc, and this engine is connected to a eddy current dynamometer or a generator through this sprocket and chain. And whenever the engine is started, here for starting the engine no electrical starting facility or auto start facility is not available. We have to use this kick pedal, and we have to, by using this kick start pedal, we can, by using this pedal like a regular bike, by using this pedal you can kick start the engine. So here not only the engine we have, this engine is also associated with the gearbox. So gearbox is also associated with this, so we can change the gear or we can put the engine in different gears. Initially in the neutral we are kicking start the engine. Once the engine is started, we can change the gear to first, second or third, fourth, etc. But generally for the load test we may be using the second gear or the third gear in the not the top gear. But we can conduct the experiment at any gears. There is no restriction for the gear to be used, but we will be using generally the second gear or third gear in the experimentation. As the gear is changed to higher levels, the RPM of the output shaft increases, so the generator speed also increases. So the generator speed depends upon the gear we have selected for the particular experimentation. And here you can see this is the carburetor, and the carburetor is linked to this device here, and here we can change the RPM of the engine by operating this knob. So when you rotate like this, there will be cable is pulled and it is operating the throttle valve, and you can increase or decrease the engine speed by operating this knob. And for a given speed, once initially if we run the engine at a given speed, first no load test will be done without switching on any load. Here as I told you, loading is nothing but this is the generator, and the generator or eddy current dynamometer is communicating with these various coils 1, 2, 3 and 4. These are the heater coils, and the heater coils will be communicating with the generator output. So we can communicate or we can start heating any of these coils or all the coils. And now once the engine is started, and we can use this arrangement here for loading the engine. You can see this lever or the switch. When I use this switch, 1/4 load means one coil will be connected onto the generator, and it is 1/4 load. Similarly, when I use this one simultaneously with 1/4 and this one, 50% of the load or half load will be applied on the engine. Similarly, 3/4 load and full load can be applied on the engine. So initially these positions will be in switched off condition, means no load is applied on the engine. Engine will be run at the idling at the no load condition, and we are going to note down here. You can see this is the fuel tank. Fuel tank is connected with this fuel flow measuring device, and with this knob we can control the flow of the fuel from tank into this measuring device or from measuring device to the engine. So here each time in the experimentation we are noting down the time required for consumption of 50 cc of fuel. Each time it may be no load condition, 25% load, 1/4 load, half load, 3/4 load or full load. For each experiment we need to note down the time taken for 50 cc fuel consumption. And at the same time, once the engine is stabilized for a particular speed, we have to note down the fuel consumption time, and at the same time you can see this is a U-tube manometer, and one side of the U-tube manometer is communicating with a box here, and this is called as the air box. This air box has an orifice, and the orifice diameter will be considered for calculating the volume flow rate to the engine or the air consumed by the engine. And you can see one side is connected to the air box via this tube and another side is open to the atmosphere. So now the engine is not started, so you can observe the water level in the left and water level in the right limbs is exactly same. But when we start the engine, one side the engine suction is applied, whereas on the other side atmospheric pressure is applied. So due to the difference in pressure, this side the fluid will rise and this side the fluid will be lowered. So the difference in the limbs water column should be noted for calculating the air consumed by the engine. And similarly, as we did already discussed, we need to note down the various temperatures. Here you can see this is the exhaust manifold of the engine, and exhaust manifold of the engine is connected to a calorimeter, and this is the outlet. After passing through the calorimeter, the exhaust will be released out. Now we have one temperature we can measure at the calorimeter inlet, and another temperature we can measure calorimeter outlet. So we need to note the temperature of the exhaust gases at this point and this point, and once it enters this calorimeter at the entry and at the exit. So 4 temperatures for the exhaust gas we are noting down, and at the same time the ambient temperature or the room temperature is noted for each load whenever we are using it, maybe 1/4, half, 3/4 or full load. So each time we need to note down all these temperature data for getting the heat balance sheet for this particular setup. And the major care we need to take while starting the experiment is, since this engine is designed for a motorbike and we are using it as a stationary engine, we need to provide the cooling system. Sufficient cooling should be provided for the engine during experimentation, otherwise there will be chances for the seizure of the pistons. For that purpose we are using one fan here at the side, and we have one more fan at the top. Simultaneously both fans will be switched on. This fan at the top and this fan at the side will be switched on whenever the experiment is in progress, so that we can provide sufficient cooling air or through the fins as a safety feature. And the another important thing we need to consider is, for knowing the gas temperatures or the temperature taken by the calorimeter, we have been provided with a rotometer, and through the rotometer we can adjust the water flow rate, that is the water that is being supplied to the calorimeter. So calorimeter water inlet temperature, calorimeter water outlet temperature, and calorimeter exhaust gas inlet and outlet temperatures can be measured. So by using these temperatures we can calculate the heat input and heat expenditure parameters for this particular setup. And here we have a multi-channel digital temperature indicator. By using the knob we can set for different positions like T1, T2, T3, T4, like you can say T1, T2, T3. So different temperatures. Just by operating this knob we can measure the temperature. Sensors are communicating with this device, and directly we can get the values of different temperatures parameters of this engine setup. That is, engine calorimeter water inlet temperature, calorimeter water outlet temperature, calorimeter gas inlet temperature, calorimeter gas outlet temperature, and also the ambient temperature. Here, this is the device to know the RPM of the engine. So, RPM of the engine is measured by using a sensor, magnetic pickup type sensor, and or otherwise directly we can use a contact type or contactless tachometer, and we can note down the RPM of the engine at each setup. So, the various parameters needs to be properly adjusted, that is the water flow rate and the RPM of the engine needs to be properly set, and then only the engine should be loaded in sequence. Initially no load condition, next 1/4 load, all readings are taken, next half load, all readings are taken, and the procedure repeated with the 3/4 load as well as the full load. Once the experiment is over with the full load, now we need to gradually unload the engine by switching off each in sequence the coils, then the engine will be completely unloaded. Before switching off the engine, we need to unload the engine so that it will not affect or it will not damage the components of the engine. So one should be very careful while doing the experiment, because this chain and all these rotating components are unguarded. So one should be staying not very close to this and in safe position. The student should be away from these rotating components as a safety parameter. So with this procedure, we can note down all the important parameters which can be used for calculating the engine efficiency, as we have already discussed in the earlier video. Thank you.